Good evening all. Today we are going to discuss multi-carrier modulations and how exactly OFDM is adapted in LTE 4G system. If you can see the diagram, key steps in the OFDM communication system are briefly shown below. This I can explain in next slides. OFDM system is a vector notation is given in the diagram, where the step 1 is break OFDM signals, broadband signals. It break into broadband signals of bandwidth B into L narrowband subcarriers. Each of the bandwidth B by L, and each subcarrier experimental flat fading ISI free communication as long as cyclic prefix and exceed delay spreading U. The L subscriber for a given OFDM symbols are represented by vector X, which contains the L current symbols. Step 2, L dependent narrowband subcarrier are created digitally using an IFFT operations. Step 3, L independent narrowband subcarriers created digitally using IFFT operations. Step 3, FFT decompose the ISI channel into orthogonal subcarrier and cyclic prefix of vector V must be appended by the IFFT operations, and the resulting L plus B symbols are then sent to the serial through the wideband channel. Receiver operations also can be given by the vector notations. We have to discuss mainly in OFDM and LTE. There are OFDM, generally we are using so many technology are using mitigation of narrowband fading. They are using the spatial diversity, coding interleaving, automatic repeat request, but combining narrowband diversity technique, but adaptive modulation coding AMC, that is LTE is adapted orthogonal based on AMC. OFDM in LTE, just you can see it very well. The practical idea of the AMC adaptive modulation and coding, it uses the possible realizations of the AMC using three different course rate, 1/2, 2/3, 3/4, 3 different turbo cores using modulation type as QPSK, quadrature phase shift keying, as 1 QM, a type of phase shift keying using 1/2 code. 16 QM means quadratic AMC. Adaptive modulation coding use 2/3 turbo code, and 64 QM use a 3/4 turbo code in possible configuration with LTE. Transmit at high rate data rate as possible when the where the channel is good, and transmit at lower rate when and where the channel is poor. This is the strategy of the OFDM technology of LTE in order to avoid excessive drop packet. Low data rates are achieved by using small constellations such as QPSK, QM by using 1/2 turbo code, and low rate robust error correcting codes such as rate 2/3 turbo code is 16 QM. But the higher data rate are achieved with the large constellations such as 64 QM by 3/4 code. OFDM LTE, just we can see the X symbols are using the parallel. We are having converted into at the end of the things, it is using digital to analog converter using the noise as a analog baseband multiple signals. It convert to RF subcarrier. This signal is the receiver. This is parallel to serial converter. What are the parallel signals in the beginning of this particular diagram? Cyclic prefix, they are converting, and signals all together they are coming to serial and sending onto the line. See, this is same as which we have discussed. The table shown below, that is a summary of key OFDM parameter LTE. This all define how ejected description relations and LTE values of the OFDM LTE. Their R is given by the formula that comes to 21.9 megabit per second, generally in 16 QAM with the normal cyclic prefix. Timing frequency synchronization of them is required to find the symbol timing carrier frequency CFO. Time frequency synchronization, you can see very well how exactly it goes in the diagram. Then challenge of timing frequency synchronization is nothing but if the timing window is slid to the left or right, the unique phase change will be introduced to each of the subcarriers. In result, carrier frequency misaligned by some amount delta. Then some of the desired energy is lost is referred as intercarrier interference. You can see the thing timing synchronization, how it will be done. We have a L data symbols, which will be prefixed with the delay spread, and postfixed also it will be a delay margin we have put it. Okay, this is the cyclic prefix is nothing but the delay spread where between we are defining putting in the gap, okay, between two data symbols. And same conclusion we are making it into the frequency synchronization LTE also. This is the thing, okay, that's all it is.